But there is some new stuff that they've just released this week that I think would be interesting to you guys. So it'd be interesting to see your opinion on it and maybe get some pointers as well. So what I'm going to talk to you today about is the Kinect 2 SDK for Windows. I've also brought along the original Kinect as well, because as they're bringing features out, they're moving towards feature parity, but at the moment the new device isn't, every feature that was on the old one isn't on the new one as well. So first I'll take you through the new bits, and then I'll go back and show you some of the other features that will start to appear. Got quite a fairly small group, so if you've got any questions as we go through, don't hesitate to interrupt me and ask me stuff. So, being game people, I would imagine that you would remember not that long ago when the Kinect first came out, it sort of hit the world by storm and revolutionised the gaming industry a bit. So we went away from having the controller with wires to having nothing in your hand at all and being able to use our Xbox. So it took out the Guinness World Record for the fastest selling peripheral device, which is pretty amazing. The thing that Microsoft didn't kind of expect to happen was everyone else wanted to use it for more than just their Xbox. It took probably a week or two before people had written their own drivers to connect to it so they could use it on their PC. And then not long after that, they kind of cottoned on to the fact that people wanted to use this thing on more than their Xbox. So what they did was they made an official, they went through a beta process, but they did come out with an official Kinect SDK for Windows and a separate device. Did anyone here know there was actually a separate device? A couple of people. I've got one of them here. They're very rare in Australia. It looks really, really similar. The thing you'll see that's really missing is the word Xbox. That's really the way you tell by looking at it. It has a couple of minor different changes. It has some extra features for a concept called Nemo, which I'll talk about a little bit later. And it also has some USB power surge protection to stop you blowing up your laptop. Which I've used the Xbox Kinect on my computer before and never had any problems. So it was quite popular as well. People have been using it for almost 2 years now. It's almost 2 years. So now they've moved on to the next next device. And how many people here have the new Xbox? Yeah. So the new one looks a lot like your Kinect on your Xbox. So what they did was they released a concept called an alpha program. So people could sign up to play with the new Kinect while it was in alpha. And what they did was they actually let us use the SDK, and we're allowed to talk about it, we're allowed to blog about it, and we're allowed to show people. And then as we're going along this alpha program, they're adding new features all the time. So there was actually a new drop on Wednesday. So the stuff I'm going to show you today is absolutely the latest. So the first alpha device is essentially, when you see it, it looks exactly like the Xbox One, because it is the Xbox One. But what they do is they flash the firmware slightly differently. So you'll see up here, I might show you John's, because his is probably not quite as interlaced as mine to everything. So you'll know from your Xbox that if anyone's an Xbox One, it plugs straight in. But because it's a USB 3 device and it's got power through it as well, we can't plug that straight into your laptop. So what they had to come up with, so you have this funky proprietary cable. Everyone has proprietary cables. Can't plug that into your laptop. So what they did was they made this funky little box so that you could plug the Kinect into that, and then that would split out into separate bits, so you could fit the power through, and then you could fit the USB out so it would plug into a normal, so that's your power.
Xbox
and then,
power supply.
Yeah, and then your sort of more custom cable that would then go into a normal USB 3. So at the moment it's quite chunky.
Does it actually need USB 3?
Yes. Yes. And I've got a photo of that a little bit later on. I'll show you they have released photos of what the next gen will look like, and they've reduced that down quite a lot, because at the moment we're running on like the full-on Xbox power supply, which is quite expensive. And at the moment they're very regionalised, so you can't use a US connect anywhere else or it'll go bang. So you have to be very careful about which one you use when you're in different places. So the main features of the Kinect that they've moved over to start with is all the different camera functions and streams that come through. So the first one is it has a full color camera. So this is, you can't see the space in the way, but you'll see the camera there. So the difference between the original Kinect and the new Kinect is that the new Kinect is full HD at 30 frames a second. The old Kinect, it could do up to 1280 by 920, which was always a funny one, up to 30 frames a second, and you very rarely got 30 frames a second in full res. You generally could get 30 frames a second if you're running 640 by 480. With the full HD, you generally get it at 30 frames a second unless the lighting is quite low, and then it might drop back to 15. Just show you, I don't know how many people are devs here, but some of these are just sort of some bits of code to show you sort of how easy it is to hook some of this sort of stuff up. So we have the concept of the sensors. So we tell the sensor to start. We tell it which frames, what sources we want to listen to. So we have a color frame source, and we just want to open that sort of color frame reader. And then we're just going to listen for a frame arrived event, and then in that event we do some stuff. And that's where you decide what you want to do with your color frame. In a lot of instances, what you'll do is just rewrite that and put that out on the screen, but you may do some other things. So I'll show you a running example of that. So when you install the SDK, you also get some nice little samples to show you some basics. Run that screen. Can you guys see that? No. I'm guessing.
Yeah.
So now we've got full color screen. Coming through at 30 frames, should be coming through at 30 frames a second. It's quite fluid. So now it's sort of at that quality that you can use it for things like career games and stuff like that. Whereas before, the quality just really wasn't there to use it to the color frame for anything particularly interesting. So that's one of the streams that you can get through. Your next one is which gets a bit more interesting, is your depth camera. So what the depth camera does is it gives you back for every single pixel that you ask for, it gives you how far in millimeters away the nearest object is.
It's just a bit whistling.
Okay, it sounds like a jet flying over. And what it'll also do is tell you for each one of those pixels if there is a person in that frame. So for every pixel, it'll tell you if it's consumed by a person, which can get quite interesting. So the depth frame, so the theme, I guess, between V1 and V2, everything is a lot better. So in V1, you went from getting a 320 by 240 to now you can get a 512 by 424, which again is a really odd resolution. So to pick up the people and pick up the distances, in the original Kinect, by default it was 0.8 meters was the closest you could get out to 4 meters. When they released the actual specific device for Windows, they had this concept of near mode, which you could switch on, which would allow you to get a little bit closer, so you could get into 0.4 meters. What people tended to use that for was when they wanted to do sort of a kiosk app where the person didn't want to touch the screen, but they sort of wanted to be sort of this sort of distance from the camera so you could still see what they were doing. So now, because the camera has a much wider field of view, they've got rid of the need for having near mode. So now you, by default, out of the box, you get from 0.5 all the way out to 4.5 meters. It does actually pick up objects a lot further out, but reliably 4.5 meters is as far as it gets with the depth camera at the moment, which for this gentleman here who was just talking to, he's doing lots of interesting
camping, it's a little bit short,
Yeah.
except if you're doing like room size things.
Yeah.
But for bigger spaces, yeah, I think lasers the way to go.
Yeah. So for the moment, it's still sort of aimed at that sort of lounge roomy sort of size area. It's not designed for a massive open space. So this one, this is sort of the depth frame code, which looks really, really similar. So again, we just start with the sensor. You tell it you want a depth frame source, so you can set each of these separately. So you can have one at a time, or you can have all of them. So you decide which streams you want to listen to. And then on your frame reader, that's where you do your function processing. Now this is where it gets really interesting in what you want to do with your depth frame. Do you want to change colours? Is there a different distance away? Do you only want to show stuff that's within a certain distance? Do you want to pick the person out of the frame?
That 30 FPS you get in your color frame, is that assuming no other sensors being read, or does that?
So, okay, so it'll depend on,
What do you do?
so it's USB 3, so it'll depend on how good your USB 3 connection is, how many things you're running on your computer, and how fast your computer is. This laptop is, it's fairly new, and it gets it most of the time, but if you're running it on a computer and you don't have, you have like lots of other stuff running, you will see it start to slow down a bit.
But do the extra frame sources have impact on each other?
Only if
If
your
the-
computer isn't up to it. But you're more likely to see it slow down overall
Yeah.
background, unless you're running, I usually run all three,
Yeah.
because I usually want to get to skeleton, and
Yeah.
sometimes I won't use colour, but yeah. I'll show you some code a little bit later. I'm not sure how much you want to see. So this is an example that they've used of the depth basics, and they're showing different, currently the pixels slightly differently depending on where objects are. And as you can see, as I move further away from the sensor, I don't know if I'll get to 4. So when I get right to the back, you can no longer see me. And as I start looking closer, you can start to see me pick up. And like the definition of my body is pretty good. If you'd used the previous one, this would used to be really, really jittery and really pixely. And then as I move closer, I won't know when it stops out, so I can't see it. I'll eventually get too close and it won't be able to see me at all anymore. And then I'm pretty much covering the sensor at that point. So this is where you can decide what you want to do with it. Because you have the ability to know that a person's in the frame, you can do some interesting stuff.
What happens if your legs are covered? Does it extrapolate really out?
If the laser's covered,
Yeah, like you're standing behind a desk, for example,
yeah,
to tell skeleton basically versus or
yeah. Can I talk to that when I do skeleton in a minute? Because it'll make more sense. So yeah, I guess I'll probably give it away to some extent. So then you can do things. So this is using the color camera, but also the depth camera to know that there's a person in the frame. But then what it's doing is it's putting my color pixels over the top of the other image that's there behind me. So you can use it for stuff like green screening. So this has got a lot better between the versions. The original one, you used to have to do a smoothing algorithm to work out between the edges, and it used to be really quite bad with hair. It's got a lot better now where it's out of the box, it's pretty much as good as they got it with their smoothing algorithms. So this is just picking out for each pixel if I'm a person and putting my color pixel onto the screen for the depth camera. So the skeleton tracking, which I think is one of the most interesting ones. So what it does is it tracks skeletons of people, not dogs, not cats, people. And it has to be people of a certain size. So I've got a Chucky doll. It does not pick him up. The smallest person I've seen it work on is about an 80-month-old. Smaller than that, it doesn't pick them up with the algorithm. So again, this is really improved over the last couple of versions. Originally there was about 20 joints that it would pick up. So think of the when you're thinking about the mannequin, that's what the skeleton was like. So for each joint, you get a head, you get a hand, you get an arm, you get shoulders. They've added a couple of extra joints, so you've got better hip alignment now. Before it was a little bit out, and it's introduced the thumbs, and it's introduced a couple of extra center points in the body. Originally, you could pick up 2 people full skeletons and another center mass of another 4. With the new Kinect, you can track a full skeleton of 6 people at once, and it also has the ability to track a couple of hand states, which I'll show you in a minute. So it knows whether your hand, for 2 hands on up to 2 people, it will know if the hand's open, closed, and they have a new one called lasso, which is sort of like this sort of shape. So I'll show you that one because it's kind of cool. This one has some of the coolest properties. It's they have this concept of body count, which I just always think of. I've just killed someone off. So yeah. So as you can see, there's my full skeleton. You'll see that it's picking up my hands. When my hands are open, they're green. When they're shut, it goes to red, so that's closed. And if I go to lasso, it goes blue, and I can have them do separate things. Open, shut. And then I don't know if I've got enough space, but if I could get a couple of people to come up, we'll see if we can fit 6 of this on the one.
Get someone to do a dance.
Dance.
You know, room 6.
I don't know, fit 6. 3. If I can go for a bit.
Trying to get to 6.
Normally you still have the space.
It's got a sword.
Who wants to in front?
What is the width?
Should be probably just put it out of the
Move it back a little bit. Yeah. And twist it.
Matt is very dancing.
And then,
I mean, you know, it's not included elbows.
It's going well, Max. You were like rolling around the floor.
Yeah.
It's still
Yeah,
It's
so-
still rocking.
A couple of things I'll point out. So you'll see some of us have solid lines for joints, and then some of us have sort of white lines. So if I like put my hand behind my back, my arm goes like skinny white rather than solid green. So what it does is it has a concept of tracked joints. So it knows whether or not it can fully see it, or if it's inferring where it is, which is to your point there. So if it can't see you, parts of your body, it'll try and guess where they are. So when I move behind the counter, my leg, it can see this leg because of the hole, but it can't see this leg because it's solid. So it knows where this leg is, but it's having you guess as to where that leg is there. So that helps you decide whether or not you want to trust the data or not. So it's having a bit of a guess. A lot of the time it'll get it right, and other times it'll get it completely wrong. So you might have seen when people move behind each other, you'll get sort of it looks like a skeleton that's been like blown into pieces, like their arms and legs will be all sorts of different directions. Like that, yeah.
That's a big note.
So, how much control do you have over that hand state tracking?
So he works it out himself. Working out who you assign it to, there's a couple of different roads that you can get the skeleton into, so it knows
You sort of
which
assign.
two it's tracking, and it'll switch. You can trick it as well if you have one person like have their hands behind, and then someone walk up behind them and stick their arms out. And then you've got someone else's arms.
We should do that Shiva thing where we all line up with one.
Wow, somebody handles from
I don't think it handles 6 very well.
We've got space, like we don't have a lot of space. So you can see on the bodies.
They made it look so cool.
Thanks, guys.
Yeah, it was just funny. Yes, like some of them were all competent, trained,
So with the skeletal training, for every one of those joints, you're getting the X, Y, and Z coordinates in space. So you know that the arms move closer to the Kinect versus further away. You also know the orientation of the joint, so it'll know which direction you've twisted your arm in, so you'll know that the thumb starts to move and stuff as well. So I've seen a lot of people start to use this for really basic like modelling of people, so instead of getting to do little dots and getting it measured, like they'll do a basic skeleton run through and stuff with that. Yeah.
Has anybody set up, with the original Kinect, there was people using a setup with 2 Kinects to get better fidelity? Is anybody doing that with the new one?
Okay, so the new one doesn't have that feature yet,
Okay.
but in theory, eventually it's going to have 4.
Okay.
So that would be 24 skeletons.
No, I mean, but what they were using for was get better fidelity on the capture of one thing. Because when you're doing mocap, which is what you're talking about,
Yeah.
thing,
Yeah.
you generally get match, and you're trying to do it as something that's going through animation, but you're trying to get one skeleton at a time, and you want as much fidelity as possible.
Yeah.
With the original, there was quite a good setup where you could use 2 Kinects.
Yeah.
It
So
might
they
not
have.
have been, it may not have been
different
Microsoft
styles.
SDK, it might have been the other one, but there was a product that was able to use 2.
Yeah.
and
So
get
the
one.
original Kinect, you can plug in. You can plug in multiple Kinects as long as you have separate USB controllers in the computer. And it could only track 2 skeletons at once. But if you're only tracking one person, you could use it to track 2 different sides of the same person.
Yes,
so
that's what I
you
used
can
to
set up
do.
multiple
Better.
Kinects. Yeah. This one will have that ability. It just haven't moved that feature across yet.
Yeah, is that a software thing that needs to be written, or is that?
Yeah, it's a software thing, and they need to be able to handle all the data.
Yeah, fair. Well, yeah.
If,
So they've like,
if you're doing any post-production, you could use 2 computers.
yeah.
Yeah, that's what.
2 sensors, 2
all-
computers. Married up.
We should have a fast computer and have the 2 USB 3 ports on a set enough bus.
Yeah, at the moment it doesn't, like, you have 2 Kinects plugged in the same computer on the new one.
Okay. Is that a limitation of SDK or is that a limitation?
It's just the limitation on the features that they've like got to at the moment. So pretty much they've got this massive backlog of stuff that they want to move across.
If say I was was not using that much SDK and I was reverse engineering the drivers,
yeah.
could I physically do that with the device? Just as I'm not doing it, I'm just as a for instance. Is it be?
I don't see why you couldn't.
Seems
Okay.
like the device is just giving them depth and
You're
colour.
Yeah,
and
you'll
and
get
what's
different
going on,
colours. You
just
have
all
to
the-
write your own skeleton.
Yeah.
It depends on what they're doing
Fair
with the
enough.
actual light modulation. So the original one had structured light,
Okay.
which doesn't interfere as much.
Yeah.
But potentially, if this is a fixed modulation wavelength, then they could, two devices could interfere badly. So other depth cameras on the market for robotics have selectable modulation frequencies, so you can put different devices on different frequencies so they don't interfere.
Guess what you do
So
if you were
for-
using like a mocap scenario, you use the infrared camera almost exclusively with the ball suit, I think would be the way they do it. You use as many cameras on the scene as you like in that.
But if you want the depth feedback, they have to have some facility for changing the modulation frequency per device. And that might not be in your hardware design.
Thank you.
Yeah, I don't know what
Probably
they've
more
done.
accurate
There's no
to use
information.
IR and use like a traditional ball suit model.
Yeah. Yeah, there'll be no interference then.
And there's also plenty of software support available and readily used.
But yeah, you will actually be able to use multiple Kinects in the future.
Okay.
Right. Yes. They're getting there. So we kind of just touched on it as well, is the infrared. So they've changed the way they do infrared between the 2 versions as well. So now they're using a time of flight. So the quality of the infrared can't even work. Too much light.
You need to get close to it, you know.
So as I get closer, it's actually like you can see, you'll pick up all like the creases on my jeans and the creases on my shirts. The previous version, you would not get that. You just would get this like really dotty outline of a person. But yeah, it works extremely well in the dark. We set up a test for a project we were playing with, and I totally forgotten about it and left it running overnight. And then came back and was looking at the data next morning going, why have I got so many like records in my database? It's because it's been picking me up walking past it during the night when I'd like come down to the fridge and stuff. Because I totally forgot that it'd still see me in the dark. So for the skeleton, it's similar again. You tell it you want a body frame, and you listen to that particular reader. And then the only thing that you have to do differently is you have to use a multi-source reader because you need to be able to get the depth and the body index in one go. So you can join these together and tell it that you want to listen to all three in one go. So a couple of different things that are different between the two actual sensors. The original one, if you had it on your Xbox, you'd notice it used to like really turn it on and go up and down with the tilt motor. They've got rid of that now because of the much wider field of view. You can pretty much set it up how you want it and it's fine. It's got its own little tilt, but it's not a motorized one because it tends to pick up such a wide field of view. The new one's USB 3, so you need something with USB 3 for it to really get the data through now. But it also means that you'd be able to get so much better quality data through that one little pipe.
Is it Windows 8 only? So
Yeah, Windows 8 or 8.1 at the moment. The original one, you can only run a single app at any one time with one sensor, whereas now you can run multiple apps. So you can have like one that's running just a little app for color, little app for the infrared, little app for the skeleton, or using the one sensor at the same time. That's quite cool as well. And one of our favourite features now is the tripod mount screw on the bottom. The old Kinect had this really stupid bottom on it, which was kind of useless. You used to have to buy this, it was like the TV mount, and it'd clip on, and then you'd throw half of it away because you just wanted to pretty much get the tripod screw out of it. So now they've like added that to the bottom, which makes it much easier for mounting.
I just had a great bottom blue cap on mine.
Which gaff tape we've used a few times as well, it tends to work well, but yeah, to have the tripod screw was a nice little design feature for a lot of people, because as soon as you didn't have it sitting on a bench, it was kind of really hard to do anything with it. So yeah, so for the hardware requirements at the moment, you need Windows 8 and 8.1 with a 64-bit processor, fairly chunky processor with at least 2 GB of RAM and DirectX 11 compatible graphics card and USB 3. Most of the modern computers I've seen so far have had no troubles running it. I've got a little Surface Pro. It runs it a little bit slower, but it does work fine on it.
Is the SDK available to native code, or have they locked it down to .NET as well?
Okay, so you can do C++ and .NET, so like C#, F#, VB, .NET. But yeah, at the moment you can't do anything other than that. So it's still Microsoft stack. If you wanted to use something else, that's when you need to grab one of like the open source frameworks,
Right.
which they don't officially support if you've got your device.
So you can on mono on them.
Where would the open SDK on? I would imagine. Because there's a lot, because you've got a hardware interaction layer, which means driver support, direct driver support, and the one of the things you'll generally find with anything Linux that emulates the other thing, unless you're going full machine emulation, you're not going to get emulated drivers. Which is a pity, because I'd really like to play Rocksmith on Linux. But even that, it needs hardware detection. But no.
So what they just, like this one that came out like on Wednesday, what they've added to it is the ability to do Windows 8 store apps. So you couldn't do that before because it didn't play nicely with the Windows team, so you wouldn't be able to get it into the store, which now also means that you can use it with Unity, which I don't know anything about, so I can't actually help you with that. But yeah, I've got Unity Pro. I've got that installed on my computer, and they do have like a little add-on for it, but I have no idea how to use it yet because I have never used Unity because I'm not a game programmer. But you can do stuff with Unity. There is a few little demos out there to use it with Scratch as well. So if you've got that, you can send out all the feed into your other apps as well if you want to like also look at something else. So that's pretty much where they got to so far with the new sensor. So it's basically just moved the streams across rather than all the little extra add-ons that they started to put into the original controller. So a lot of people are starting to move their code across, and it isn't a big jump. So if you've already done, like, has anyone done the Kinect app? Well, you get stuck in trash, it's even better. But if you had done like the 1.8 on Kinect 1, like the code isn't that much different. So it's not that hard to shift it. So the concepts are all still quite similar. You still have those frames and screens. Before I show you some of the other features on the old Kinect, just wanted to talk about a few of the different things people have been using it for. So pretty much all the different industry slices have used it for different things. So it's been quite popular in sort of like education to get kids, out of their seats and doing some stuff with education. There's been quite a few like math programs and stuff to get them doing angles and algebra. And sort of like just fun sort of like gamey type stuff to get them a bit more interested in their schooling. One of the big ones it's been used for is health. There's been a lot of projects done on sort of like physical therapy. So if anyone's ever been to sort of like the physio and they give you that sheet of exercises you have to do, and you never know if you're doing them right, and they're boring, and you stop after about 2 days and you don't know if you're doing them right. There's been a bunch of different projects done on that now, sort of gamifying that physical therapy. So to get your shoulder muscle going again, you've got to chase the fish basket around the screen and get it, and it's making you move your arm in the right direction. And then they can take that feedback and give it back to the physiotherapist to make sure that one, that you're doing it, and two, that you've been doing it correctly, because that's kind of the most important part of it. So there's the health aspect. There's been some stuff done around sort of like surgeries as well. So sort of like that touchless environment where every time you in a surgery, as soon as you have to touch something, you have to scrub in again. So it adds a lot of time to the surgery. They've used Kinect to allow doctors to use gestures to move through screens of X-rays and stuff like that to cut down surgery times by amazing amounts, because they don't have to take their gloves off, scrub back in, come back in again. Retail has been pretty phenomenally penetrated as well. So they've got the virtual clothes shopping. They've got sort of coming up to a stand and interacting it through the window, so people can get to stuff at night time when stuff's closed. So the car industry's been using it as well. So people explore through their car where they can't have the car in a shopping centre. They can go through the features of the car and change colours and sort of get the feeling of the car without actually having to see it. And obviously the other big one is a lot of the games have started to use it as well. So I think it has an interesting feature. It's got so much tech in such a little device, I think, is one of the main things. So what sort of other stuff are you guys interested in seeing Kinect?
I'm considering using it for rapid prototyping. One thing that you can do really fast now is modeling characters. I was thinking of using Play-Doh, and it'd be a really cool way of just if we had a rotating base or something, or play with some shapes and try to model them really fast. And then maybe rig them using the skeleton stuff, and then doing poses and stuff, bring that out. Are there any tools for that there?
Not so much tools. So the original one, you could do some sort of avatarium stuff with, which I'll show you. I'll just do a switch over.
Doing structure for motion stuff.
Sorry?
So it's just saying doing structure for motion, is that?
No. I just wanted, let's say we have a game where we want to do characters, but we want to do one prototype of 100 of them really fast.
Okay, so but you want structure for motion? Oh, sorry, that's where you take, you build a 3D model from images.
Oh, yeah, sure.
Yeah, that's the first, there's a couple of things, there's structure for motion, then you want a skeleton that you can animate on top of it as well, basically. Yeah, I'd love to see a structure. I should be able to do one of those.
He's talking about Play-Doh as well when he actually sculpting.
Yeah, no, that's an idea I had about here.
It's an external sample.
We've tried it with the original Xbox doing that. How do we, you've got some experience with it now.
Okay, so that one I don't have.
Does builds a model, and we've done a lot more using high definition still cameras, and that gets way better results, but it's a lot smaller.
Okay.
Do it that way. Definitely do it well. Was that? Yeah, I was doing before that, and I'm not particularly Windows native, so it's not. It wasn't the tools that I was using to do it. But, they do have I have played with their tools a little bit. We were using something called Visual SFM, and another product called MeshLab. And it's the same process. You take a shitload of. We did a lot of trees and parking. It's really good for doing outdoor stuff. You want really detailed surfaces. With that plasticine, I found that it's slightly reflective, and I didn't get the best results. I need to do more experiments on materials. Is that it?
How quick is that? Like looking at the photos and presenting?
I reckon I could get a scan done in about 10 minutes. But it was quite interesting. Like it's click, step, click, step, click. And we've actually, well, particularly for the large outdoor stuff, because you can't turn it around. The other thing is you can put on a turntable and you spin it, and I haven't done that as much.
So basically inspiration came from like the Doom sprites were made that way. That you just Play-Doh and these little little things that's not framed to like build a character, and then just have the base. They would rotate it manually. So I'm sure we can just kind of that rotates. Just look at the basic truth kind of thing to do that.
Megabot.
No, actually.
That with all 3D scale reports.
Yeah.
Okay, good.
Okay.
So which program are you using?
Visual SFM and a MeshLab to do the. Visual SFM generates a point cloud, and I'm using MeshLab to
Basically.
Visual SFM to generate Poisson. Well, I don't know how to pronounce the word, but Poisson. Calculation from that, and then you transfer the vertex colors from the point cloud to the vertices in the, and then you can do a simplification step in MeshLab. It's a lot faster than anything else I've tried. And with the Autodesk one, you sort of send it away to a web service that does a thing, and it does an okay job. With the the Visual SFM plus MeshLab workflow, you've got a lot more control over the process, which means you can potentially get high detail meshes out of the same stuff. It's more work. You do it locally, you need a fast computer, and I have not seen something suck up 8 cores and 10 gigs of memory so quickly and hold it for hours, as much as doing point cloud calculations.
There's also CVP MPS, which is
Yeah,
like
that's
bulk
should specify that to do the high. Visual SFM does it in a 2-stage process. It does, and that's why I use like Visual SFM, so I can do a quick one to see if it looks like it's going to work.
Yeah.
And then it farms the work out to either that one or the PMVCS. There's two.
Yeah.
There's one's available only on Windows and is really good for doing sort of specifically built for doing large scale stuff where we have geo-referencing involved. And there's another one that more or less does the same thing, but it's a few features less, and that is where most of the work time in the workflow is spent actually in CV. Currently.
Yeah, the dense reconstruction.
Yeah, the dense reconstruction is just that.
So the topic we're talking about is creating a full 3D mesh of an
Yes.
object.
From,
So I think
from the image data.
from image data. So I think the key thing with the Kinect is showing, this demo is probably showing it well in 3D space, is that you would either have to rotate the object.
Yes.
I mean, the Kinect has
With
3D
the Kinect
data,
one,
it's a single
there's
plane of data.
Few nice little outlets
being
will
shown.
that you put a person in a chair or put an object and spin it. And
So we'll show Kinect Fusion
Yeah,
next, but I think this is the view, the 3D view that.
Oh, yeah,
Yeah.
So this is it in 3D. Bronwen can actually spin the 3D view around, but clearly the Kinect can't see through objects because it's only got a single point
So
of
you
view.
see when it gets sideways, you can only see like to there.
Is that not right? Is that
I'm
not
just
right?
replaying at the moment. Yeah.
Oh, okay. This is their studio, which allows you
So
really
you can
good
make a
develop.
recording and then you can play it back, which is really good when you're debugging. So like when they didn't have this, they used to have to like I did some code and then like you have to get Johnston out in the front and do stuff in front of the Kinect while I'm debugging it. So they have this studio now where you can record all the streams in real time and then you can play them back and then you can send it back to your code. But it's quite cool for also checking out what happened in each different frame. So you can record it and play back. You can play back the whole thing. So you can see, and then you can move around in 3D space. You can see different points.
Is that the one Kinect or the 360 Kinect?
That's the one.
This is the one. You can do the same thing on the old one. This is brand new, like they only released the studio in from Kinect 1 on Wednesday.
Yeah.
They didn't have this before, which was kind of annoying.
Yeah.
See that
You can
sort of
put
point
it-
cloud?
Record. So that's it. You can see that in the last one. So you can see.
And then as it's walking around, I can see.
And so you can see that what the Kinect is really good at is, as a very cheap device, is being able to open up for indie developers the ability to do skeleton capturing,
Yeah.
to do some basic sort of depth mapping. It's never going to replace the high-end equipment or things you can do in
That's
post-processing.
why I was specifically interested in really put multiples up, because with the previous generation, you actually get much better results with multiple Kinects.
But this, so, and I guess what we're showing here is that that's the raw data you get from one. You can imagine with enough programming in your own software, you can combine 2 or 3 very separately. You can record the streams and integrate them yourself.
Yeah.
Software, obviously a lot of work. But out of the box, with 3 lines of code, you can get yourself 6 skeletons tracked in 3D space for you to then map to models to record the data, play back later. So there's things that it can do really well in only a few lines of code. Other things where you can tap into the sensors would require a lot of programming extra work from yourself, and which has probably been solved by other people using multi-dimensional cameras as well. That comes into account. But do you want to do Kinect Fusion?
Yeah.
In the case with structural motion, you're doing that with multiple angles, and then the software is triangulating the points from each of those captures.
So you,
And within a certain degree of
Fire.
error, they can figure out the full reading.
yeah, we'll show you that's on the next one.
Yeah.
So just hit reset. Should we use just? Do you want to?
That's good.
Okay. So if we hit reset. No. Oh yeah, you need to hold still.
Well, if you don't, you sort of get that sort of terminator 2, like, disappearing.
So how long is that?
Yeah. So that's
That captures that.
yeah, and you can reset. It's actually a lot to do with it's the processing power of the computer. I mean, this isn't something magical in the Kinect doing this. I mean, it's able to get
Well,
depth
it's
of data.
depth. Well, but you can do it with, you can do the same thing with standard photos. It's triangulating the points between the different photos and using pattern recognition. And
That's,
the
yep.
depth buffer in the Kinect potentially makes the process a lot easier.
That's exactly it. It's a bit of a shortcut because for every pixel it knows the exact depth. It's a lot easier for it to create that 3D model than having to do feature matching across a photograph.
Does this work with the newer Kinect as well?
Not yet.
But will, and hopefully we'll see.
Hopefully, I will see
Amazing
the
fidelity
fidelity.
increase.
Yeah, I was going to say with the extra fidelity and the fact that it doesn't need near mode. I think it's a lot more.
I've got a few
Models on this.
But the fusion stuff is definitely where you notice the difference in how good your computer is. When I had an older computer that I upgraded, like the fusion stuff was just so much quicker. Like if you're running a really old computer, it will take like minutes and minutes and minutes for it to like sort of render properly. Whereas if you get a faster computer with a faster graphics card, it's so much faster. Like stuff with the keyboard, like picking up the detail on the keyboard. Yeah.
Is this a feature of the SDK or this is a particular sort of software demo? Do they give you source to be able to do this yourself? Kind of
No,
thing?
so this was a Microsoft research. Oh, sorry, I'll do two things at once.
So this is software that came out of Microsoft research. So it's using the data from the sensor, and what it's allowing you to do is visualize it and export the model that it produces. But they haven't released the source code out of Microsoft research.
Right.
So the actual demo was on YouTube. Went much further than this. It was doing being able to detect when an object was removed from a scene, and then be able to virtually replace that object with a virtual 3D object that you can interact with. It went all sorts of steps. But it's all obviously intellectual property that's owned by Microsoft Research that they want to commercialise. But what they did make available was the export of it.
Just to say, on the other side, there are at least four or five other products that are released by third parties that do the same thing roughly.
With the Kinect.
With the Kinect, yes. There's at least 4 or 5 products that we do against this sort of thing.
It's amazing, and that's in technology. Once you can see that something's achievable,
And I
it's
think
a lot
at least-
easier to be able to create.
I think at least one of those is an open source project.
So the export of this
rough
tool
technologies that
was
you can find
put out
code for.
Put it in the open source drive.
So there was there's been a lot of demonstrations from 3D
I don't think
printing.
it matters.
Where they use technology
Most
to scan your head.
Most of the interesting stuff is happening on the CPU side.
It's like a
Somebody's basically the standard SDK.
But I think the key
they're
here is
reversing the
this
data.
is a very specific piece of software that will either work or you might need to work out the control over. While there's
It
other
does,
software
as far as I'm aware, it doesn't, but the other,
all sorts of data.
there's another SDK that caters not only for Kinect but other similar devices that has control.
Yes, this is another example where you can export it out into a mesh.
OpenNI, I
This
think.
one does the export out as well.
I don't know where they are with Xbox, this support of this.
Yeah, I don't think there's anything yet. I haven't heard anything. So
Well, then,
it's surprising because connectors went from the 2x.
This is where I need a better computer. Oh, this thing is.
Yeah, so it's not. That's not good. It's good. You need a really powerful computer for this one.
I don't think it's.
And Kinect Fusion ran a lot of stuff off the video card as well.
Yeah. So this one, like you could go if you had this one's not going to be gutsy enough to do it on the fly. If you'd scan ahead and then you'd like create a mesh and you had a few different options. But yeah, you get that all the data and you could do whatever you wanted with it after that. So I guess the other thing that's sort of related to that they've got in the first version that's coming into the new one, and I've seen it looks pretty awesome. Is the face tracking.
You've got something else running there.
I need to be able to see the screen.
Oh, sure.
Yeah. So this one, it tracks different points on the face, so it creates that like facial mesh. And what it also does is it can track different states that you are in as well. So as you turn your head, it'll pick up. So this one does actually work on my tracheotomy. So it'll pick up all the eyes and the eyebrows and opening the mouth and stuff like that as well. So you can do, and it'll pick up like sort of concept of smiling versus frowning and stuff like that. Yeah, so you get all different points. Hang on, let me just show you the other one.
You think about how you apply that to a model.
Obviously.
Yeah, well,
First thing
you've got to think if they're rendering it that way, that's probably what they're giving
you'd think so.
back. So you can probably use it as like
I'm
a
not familiar
definition
with
target.
this particular one, but something like skeletons, so you're seeing a visualization of the raw data. That's all available to you as a developer.
Yeah.
I'm curious to know what the raw data looks like as well.
So this stuff's all in C++, which is not one of my strong points. So what this one does is it's taking that data and then doing something different with it. So it's got this little face, well actually you can do it just in the computer. So as you like, if you do a big wide open mouth and stuff like that, like the face will change. And then you roll your head and it does the interpretation. So it's like, so that's where you can get that raw data and you can do something completely different that doesn't look like the person at all with it. So you can use it to do sort of like your character control and stuff like that. So if someone's talking in like using the game, you can reflect their emotions and state of their face and stuff like that.
So is Microsoft porting these examples to the new Kinect?
Yeah, so the goal is to have feature parity by the time they release. So at the moment, this is why, like, this is the alpha device.
Yeah.
So they're releasing it so people can get to like get the bugs out there, get the feedback, the performance out there, and improve all that stuff. So by the time they release it, so many people have used it and don't have any issues. And it's also good to see it work on all different people's computers and stuff like that. Because when they first did it, they had a very small, they started with the small list of video cards. They say it worked on, but as soon as you start giving it to people, they know that there's a whole bigger list of video cards that people haven't managed to get.
Do you know when it will be released?
At the moment, they've said summer, which is our winter.
Can you hold still, just move your eyes left and right? Please.
I don't think it is that good.
Microsoft.
It's good. It picks up the eyebrows. I can't see what it's doing, but normally it draw like a brown and stuff. And I can't see if it's working, but I have seen it work. Let's see.
Microsoft say what they want to see done with this technology.
No, like they're really just seeing what people do with it. Because like what happened, like when they released the first one, they had no idea people would do the stuff that they did with it.
We were told a number of things that they wanted us to do with it.
Yeah.
One of the very, very silliest ones, and the possibly the stupidest thing I've ever heard at a conference, was that they wanted us to use this to watch the player's mood playing a video game and adjust the difficulty accordingly.
That's what Valve does internally for the QA.
They watch their faces, and when they start to get frustrated, when a player appears to be getting frustrated, then they should ramp back to difficulty.
Yeah,
When they look like they're having fun, then increase it.
So if you think the next that would, so the other one I haven't even touched on.
really useful.
They actually made it. They were like really batting for that. They wanted us to do that in the game. I'm like, no.
For focus testing, I could see the value, but not dynamically in real time.
That's what they wanted. It was insane.
So the one I haven't even touched on is it has this full microphone array as well, with speech recognition. So if you can pick up people like, I know what I do when people shoot me in the game is like I start swearing at
They did
Xbox.
suggest that. So not like that.
Yeah, it would be pretty easy when I start swearing at the Xbox because I've just been shot. Yeah, it would be good if it got easier.
Oh, they've already got it in yeah, soccer and I think that's what it looks like the new one. You get perfectly balanced swearing where you want to pick up the values from. Yeah.
Does anyone watch what has what person of interest? Yeah. So this is what I was doing last night. Oh, sorry.
I think what we're going to see a lot more of this is, so Imagine Cup will be in Microsoft's office this year.
Mystery room game.
And we do a couple of different presentations, which will go up on the web. I will bet money that there will be a Kinect 2 presentation, and they will just be showing off things left, right, and centre. They were showing off the co-parity between Windows Phone and Windows Phone 8, Russia last year, and they were showing off a few other things. So this year they'll show off Kinect on a site completely.
Sometimes it doesn't like me having broken the next one.
Bronwen showed do a restart. So this is two features that came through on Wednesday. So it was this is the ability to write Kinect as a Windows store. So as a developer for Kinect, basically you were as a commercial entity trying to develop for Kinect to make a profitable application, you were having to look at scenarios where you bundle the hardware with a software solution. So maybe it was that in-store kiosk where people were trying on clothes. You'd be able to sell that into an organisation as a complete unit. We'd have a screen and built-in Kinect and a piece of software. But what was never available was for you to be able to create just an app, expecting someone home to have a Kinect. Because the reality is they were very hard to get to, there was no real store model. So this is potentially the first step towards a store model. And that's where you can create a Kinect app, deploy it to the Windows 8 store, people can buy it and download it. They'll still need to have purchased the device. But at least it's the first step, the idea of actually having a store. So, when Bronwen tries to get us my work. So I just whipped this up last night because we watched series, incomplete series, we just back to back, we just wiped out weekends, watching 13 episodes in a row. And we're currently on Person of Interest Nowhere. And for those who aren't familiar, there's like a computer that knows what everyone in the world is doing and can predict who's going to get in trouble. And the stars of the show have to go and rescue them. And the visualization they keep showing is some CCTV cameras, but the computer can recognise everybody. And there's a fairly simple visualization which hopefully will show if it fires back up after the reboot.
So this one
Just remember.
Yeah, so I wrote this as a Windows Day app, and I literally was like, it was 2 hours. It was just basically hacking the colour camera, applying a little line filter to it, and grabbing the and grabbing the head of the skeleton and creating a nice little visualization around it. So it was pretty straightforward. So it was a couple of hours of getting familiar with the new Kinect to whip up and hopefully it won't
the biggest problems in the future.
Yeah, you can imagine how, like, I just did 4 years in a row.
Yeah,
and the stuff that the kids do.
C# JavaScript, C#.
Like, they were using it in VR, like, as soon as it was out, it's in all the projects, like, you know. And last year,
Yeah, absolutely. I mean, if I know the difference between the two.
So the top three
I understand.
Calculation was the big thing, and that was when they say calculators, they meant really good.
yeah, so you see person of interest as the intro comes up, it like does the scan of the people and it puts a little box around them. So yeah. So what is
and so that's you've seen yesterday. That's literally the skeleton visualization you saw, but just modified slightly. New XAML element, little data points are just some of the raw data you see, and I'm just scaling it based on the Z value. So as we go further away, it should kind of lock on my head.
Yeah. So John's just using the head joint, and then we're using the color camera.
So I'm going to scare the security guys at work tomorrow and just set this up in the foyer and see what they think.
Do it with that little laser pointer, servo motor that tracks your head. Instead of a little head dotting into your head.
Right, or the automated Nerf gun.
Yeah, that too.
Goes through that.
So everybody will run underneath it as well.
We can kind of like change, go from green square to yellow square to red square. The one that's in front of it.
Have a red, some people just have red.
Yeah, it does a lock.
Yeah.
But it's also the basis of, that's the square that you could chop that image and start sending off to a third-party facial recognition software. The Kinect can work out where your head is, and if you've got another piece of software that can do that recognition, so it opens up those opportunities very rapidly for a fairly cheap device. Right, well the Xbox does it, and that's...
you walk in front of the Xbox and wave at it, and you're you.
Yeah, sometimes.
Well, they reckon most of that detection actually comes from your skin colour, which I found interesting. I thought that was surprising. They reckon they distinguish members of the household primarily by the skin colour.
That's actually quite funny. So most of the can't tell me and my brother apart. Even though we're 3 years apart, they have this weird thing where they'll call me and my brother's name all the way around. They can't tell us apart. The Kinect will get it right every time. Whichever one picks up controller 1, it knows it assigns in the right person. It's never been wrong. It's always got the right brothers, the right profile.
We don't have as much luck. So our setup is we have a projector, and I think that sort of interferes a bit, and it isn't quite as good as it up.
Well, it doesn't get any colour information from it. So
Could you tell me from an image what I think
so you're going to show
the ones they use for doing that? automating sorting capture sources on
So,
capture
so the other feature that they released on Wednesday was support with Unity. Now, I literally installed Unity last night. I've never used it before, but I think there's a bunch of people in the room who are quite familiar with Unity. So I can show you what they've done, and then I'll let you say whether that's useful or not. So I've got it set up over here, because that was just the case. So this is running Unity, it's got Unity Pro. What they've described it as is they've done it as a custom plugin. Does that make sense? So it was under so it's an asset package. It was a custom package that they've created. Does that make sense to the Unity people? And so this is an example of the Kinect materials and scripts under a Kinect folder that are there. I don't know what these mean.
Oh, it has all the directs and stuff.
But you know the basic demo, if that's actually running.
No, you just turned it on. How about I just stop press that again?
Oh, play it again. Goes through. So that's, I assume if we have it pointed towards a few people, we'll start seeing some 3D information and some skeletons inside Unity. So to me, that doesn't mean a lot. I guess it means that they've got some connectivity. And hopefully that inspires the people that are more familiar with this tool to say, what could you do now? If you're getting those streams of data inside the tool that you're familiar with, could that mean that you could start doing 3D models and some avatturing? Or would you need more?
Let's assume that's
Do you know the level of fidelity of the data makes a difference? I guess you could, but the more generally is, the more work you have to do to clean the data up to get what you want. So
That
you wouldn't be
the point
making
where it's acceptable, the point where it's good, and they're not the same point. That makes sense.
Even in native, you'd be able to map that onto a skeleton pretty easily. The thing would probably be you'd probably need a model that's actually rigged to a skeleton that matches the Kinect
the distinction was
model.
creating
Would be
model versus driving model. Yeah, you can use it to drive model, that's what they do. That's like what was invented more or less, but to create a model in this context would be difficult, probably.
So that's a
Require a lot of process.
Did you guys ever do, when you guys were messing with this on the engine team, did they get as far as doing retargeting? Because I think one of the big things that have to be the slight different skeletal
It's
size.
got pretty good, the SDK has pretty good support for retargeting. The most common thing you do, or the first thing you ever try to do, is map the Kinect bit straight onto your Xbox 360 avatar, which is not quite proportionally you. So retargeting is
Doing all the chaos stuff for Ninja Turtles and putting swords in your hand, so you just stand in front of just one skeleton.
Sure.
Just retargets that onto a Ninja Turtle skeleton with a sword in his hand.
That was pretty good, they done that. I haven't actually seen any of the retargeting.
He needs that net fusion recording studio because he's constantly standing up, waving his arm in front of the camera and sitting down again. So he'll be happy once he can record that thing.
Yeah, just play it back.
It's funny when you're just in that area of the room talking to them and you look over and you're standing on one of the monitors with the sword in your hand while you're talking to them.
The trick is, the biggest trick is that like a lot of those engines aren't set up with comprehensive IK and it's capable of driving intermediary bones. Like if you map each of those bones that you get from the Kinect to a single bone on a complex mesh that drives a video game, then it's going to look really dumb if you've got a whole bunch of bones along the skeleton and only one of them is mapped to it. You need to have like an IK system where when you move that one and that one in relation, then these other ones move relative based on some constraint rules.
Well, I was actually about to say, this doesn't seem to have any constraints built into it.
No, it doesn't.
It looks like
It's just raw matrices.
It will spin an arm backwards in ways that won't match up with that.
It certainly does. It's just raw matrices. So you need to have your own IK solution sort of in front. A lot of game navigation systems don't have that in the foreground. That's like a creation tool that gets taken away when you bake something out for real computers.
With the dots though, you said a matrix. Have they actually got orientation?
Yeah, they've got orientation like before. She did this with her hand and that works.
But is that just using like, because it had a thumb joint, is it just using the thumb? Or is it like the old one?
It kind of tries. Your head, the head bones there that aren't expressed with an orientation are. If you do this with your head, it knows. If you do that with your head, it knows.
Well, that was great. Quick discussion. Right lead out of that was yes, you just already know. You'd have to have the right for. Is it would it be avatturing? Is that the right term if you were trying to drive a 3D character?
Well, retargeting.
Retargeting basically is because So if you've got like a little cartoony character,
Yeah.
the length of the legs relative to your proportions are going to be different. So there's a bit of math involved in basically retargeting a skeleton onto a slightly different skeleton, if that makes sense.
And the two other things you touched on was getting rid of the jitter and also making sure that the model didn't do something that wasn't physically possible.
Yeah, so IK constraints. You know what IK is? Inverse kinematics. It's basically the way, so mathematically, if you want to take a point and say, I'm going to use my hand to pick this phone up, it's what makes your elbow bend in a way that doesn't, sort of stretch or shrink these bones. And that's inverse kinematics. And what we usually do with that is constraints. So that you basically say, I have an elbow, and my elbow doesn't go beyond 90 degrees there. I can't bend my elbow
That
back.
bends this way.
And this looks like it actually gives you data that will bend
If
in
I take my
back.
wrist here and I put my wrist here, then the elbow must bend, and it must bend on this plane relative to the wrist, and it must.
So it's,
So the
you
thing,
have to do a bit
the
of stuff like
most important detail really is that that's used in authoring 3D animation, and typically is stripped out when you put something into a game. The distinction is that you need to keep that data in your game, and you need to have some system that understands that in real time, which is.
Has anyone looked at Mechanim with some of this? Because it has constraints built in and does retargeting.
What's it?
Mechanim, so the animation system that was
The-
added in Unity
It's
animation.
their high-level animation system.
So it does a certain level of retargeting with changing the constraints. So like the demo that they used to show it off was to map like I think they had some parkour style animation, and they mapped that into like this giant teddy bear model, which had totally different joint constraints, and it just remapped it, retargeted it, and the animations just worked with the new model.
that. And that's a Unity game.
Yeah, it's an animation system that's built into Unity itself. So they got two in there technically, but it might handle some of the joint constraints and some of the retargeting, depending on how far out they are.
And my big question is, would you be using this technology to drive like AI characters in the game for later, as like a tool? Or
So
about
yeah,
real
that's
time? Is it
probably a
about,
more realistic first step would be, and a lot of companies are doing this already, using it to do cheap mocap.
yeah.
So you get an animation, you then take that to a person who cleans it up and makes it acceptable.
We did it for all of our prototype cutscenes. Like Quantum Break was a heavy story-driven game. So we had 2 Kinects in a room and did all of our prototype cutscenes this way. They were really noisy and crap, but they were fine. And so we got the flow of the game out, and then we got actors in with ball suits and used proper IR cameras around the room.
Yeah. Well, at college you would film someone doing it, and then you'd have an animator watching that, trying to recreate it. So
So this speeds up that process, but obviously the less noise you have.
the less
And it might be that the Kinect, the new one with a couple of them all point at the same person, capturing the data and being able to smooth it out would maybe get to the point that it's good enough for some purposes without having to do a lot of manual rework.
I'm kind of surprised the SDK wouldn't just do that itself, if that makes sense. Like clearly they're putting so much software power in there. You'd think if they can clean it up more, why doesn't it just give it to you cleaned up? If that makes
Well, it
sense.
probably
Why
is
doesn't it
doing,
build out tools?
it probably is doing some degree. Some of it will be just a matter because they're saying that the SDK is still new and they haven't.
How many Kinect games have you played?
None.
Like, what you see on the screen is often exactly what you see in real time in some Kinect games. Some of them are sort of more filtered, but you often see that.
They don't clean it up.
I've seen games that look just like
Remember,
that.
this is real time. I think you mentioned it earlier
Yeah.
today. You've got 32 milliseconds to do all these calculations and put it to the screen if you're doing this at 30 frames per second.
Do they give you feedback on when they're guessing the bone so you can eliminate the guess?
So there's inferred status on every joint.
So if your hand goes out, it gets occluded, it'll still show up. It'll show up in, as a different status.
Yeah.
Because
Most of the jitters tends to be around the hands and things, which is guessing a bit more.
It's easy for them to get crossed over and not be able to get seen. But is this a possibility for third-person type views, where you might want to involve the actual, in real time, the person, the user of the game in those scenes? Is that something that's coming in the game industry?
Most of the VR is how do you move the player at the moment.
It is, but it's a harder problem.
They can't walk, right? Yeah. But is it in the cutscene they can still move their arms around and move their head, and they actually see that? I mean, is that something people are thinking of?
There was some. I mean, the first sort of wave of Kinect 1 games were sort of party games that were based around, and you can play them downstairs. There's a Kinect downstairs with connected benches, I think.
it's anything where you can stand still essentially and not have to do more than a step to the side and a jump and a wave your arms.
A lot of the newer ones as well have to like add on. I know when we got when we rebought Tomb Raider, you can do like the rotate on objects using your hand rather than just using
augmented. All the stuff we're doing, VR has been something of a game changer, and that we're probably more interested in combining motion capture with VR type, which is a different setup.
Yeah, well, we've already seen demonstrations with Oculus Rift that using Kinect to be able to model the person's arms into the scene.
We're finding better luck with the Hydra. We haven't tried the new Kinect or that sort of thing, and it's with the camera-based approach, there is a little bit of latency, and that doesn't feel as good as having something that's much more immediate.
Yeah, I don't think the Kinect would ever be acceptable for VR. VR is too latency sensitive.
But it's still something.
But that's like I was saying last time. That's why I still reckon Sony you've got to go, because the Move controllers are like a ball suit. They'll actually give them accuracy and they'll do it in very real time. And the Hydra relative to the
has been
headset.
really good for us as well.
So
What's the Hydra? It's a race thing, and it's
Well, the
it's
difference
some sort of magnetic fields.
and the difference with that though being that they're going to have to add an extra tracking point to the headset, whereas with the Sony one they can already track the headset using the same system.
Do you know if the Sony one's going to be generally available, or is it just going to be limited to Sony devices?
Apps will get a hold of it and love it.
Yeah.
Just give it a week or two.
Assuming that it's considerably better than what Oculus has.
I wouldn't be. You'd think they just released
if
it.
the Oculus is just good, why would you go Sony?
Sony has said Sony has said sorry, you were like
And anything that asks about others, they're like, just be as what it is.
So with the Unity stuff, there is actually in 2 weeks' time that Microsoft's having an event for, it's called Publish, and it's about getting people to write phone and Windows apps on the day and publish them. But in the Microsoft Brisbane office, they actually have 10 of these new devices, and we're going to be there. So if you guys would be really interested, if anyone wanted to come along to have a hack around with the new Kinect with the Unity stuff, I'd love to see someone do a game with it.
So I guess it's if you're free that day, it's a free event. We'll have the devices there available if you want to have a hack for a day.
Because you'll be able to play the SDK device that day. So it's 400 George Street.
Still on the Riverside Road.
No, it's in town.
George Street.
Like next to the Santos building.
Heading towards the Tank Gardens at the top end.
Yeah, near River Street.
We'll have to let the Unity meetup group know that that's happening.
Definitely. Yeah. So I think they got 10 devices. We've got 2. We're going to be there all day anyway. And the idea is just to get people to like do some stuff. If you guys want to have a play with Kinect, it'd be awesome to see some. I'd love to see someone do some of this Unity stuff because I know nothing about it. So I don't.
It seems a bit wasted on us. I've probably only there's only a handful of people obviously in Brisbane. So we can make them available to you guys to do something.
Yeah, the tank, the top of the tank. Well, it's more correctly as a university, but I use that way to go through the Tank Gardens sometimes. So, yeah. Sorry.
This is a stage I
Yeah. Which is between the tank. Essentially between here, this university, and the transit center. So, level 28.
Well, the Sydney one's Friday night. All the way through to Sunday night. But yeah, they're supposed to be sending us up some devices and stuff. It'd be interesting if anyone would play, because they have those devices. We'll be there.
So, is that 2 weeks yesterday?
Yeah, not this coming Saturday, the Saturday after. Yep, and then if you want to play with the current one, the Kinect Windows SDK is up online if you want to play with the V1 Kinect, and they've also open sourced their samples. So as they're adding samples, they're adding them to the site rather than having to wait for a whole release cycle. That's the main one. Is there any other questions?
Actually, can you run the SDK with some sample recordings without the device at all?
Out the device.
Give it something.
And then put them on the machine, doesn't it?
I think you need to have the device to play it back. It's definitely something we asked for. I can't remember if they actually did it.
The Kinect 2 still had hardware in it. The old Kinect was dumb, but from the conference that I went to, they were telling me the new Kinect had hardware in it to assist because it wasn't reasonable to spit all that data across a USB cable, so it had to do a whole bunch of processing in the device. It would stand to reason that you would need the device present to be able to replay it.
If they'd insisted on USB 2, it almost sounds like they.
Yeah, that's what I wonder if they thought a processor. That's what I wonder because like everything changes before release, but I wonder if they thought it was too expensive to put a processor in.
Like, can you get it? The first one you used to have a
Get an HD feed across USB 2 and 30 frames a second.
I thought well, my USB 2 webcam was that same resolution. 1280 by 960. I think that might be where the bus was at.
Yeah, and that's trying. This is trying to put more than one feed across the two if they're doing.
Yeah. So there's probably you don't have enough raw bandwidth. I forget. You can with USB 2 you can get you can only get about 4 audio, like 4 quality audio streams through on USB 2. For recording device, like when you're not for doing communication stuff, but for doing oh no, maybe you can on that. So USB 1 is it's about 2 of that. USB 2 you get more, but I think my webcam was about the same. Anyway, I'm not sure that you could even get the streams over a USB 2.
Actually, what does anyone know what the depth data? The depth data comes back as from the camera. Is it just like, is it a 32-bit linear depth or something, or?
There's a number of bits. So like the last 4 bits is like whether or not there's a person there. Then there's another bit that tells you the distance, and then there's the X and Y values, like the X, Y, Z values. So it comes back. Show you correct.
It's a massive ice stream, and then for each pixel, which is in sequenced order, it's showing you a distance, which they convert to millimeters, and then just a player index.
Wouldn't they give that as like a floating point number or something?
The distance, yeah. And they'll internally be able to convert that to millimeters for you. So there, I don't know whether in the old, because we cracked our old, lots of people cracked open the old and saw what was going on. They would have to actually calibrate the old sensor to that data, and so they would, as part of the manufacturing process, they would calibrate and burn something into a chip to do that calibration between the two cameras. The alignment, which was different on every Kinect. So I'm not sure what the new one is. In our first demo we ever did on the first Kinect in New Zealand, we cracked it open and explored what was inside it, but we only have 2 of them today. So
Yeah, I'm not getting a great one yet.
Usually fixed point distances like that. Let's set a resolution like 1 mil, for instance.
They're actually, there's actually this one item what new thing.
For a range value.
I wasn't sure what the way they do this. They're sensing whether or not it would get, more or less depth factor depending on the distance.
Of course it does. Yeah, it does. It's like non-linear, just like an auto.
Right, yeah. So it's
And like if it's time of flight, it shouldn't get too much worse. But with the disparity mapping or structured light, it's significantly worse. You see the quantizations that get bigger and bigger as you go further out.
Well, when she was walking back and forth raw feed earlier, like clearly what was showing was the low bits, the depth of it, she was walking through those layers.
Yeah, you just saw a few.
So it's clearly like the low bits. And that, they like have pretty even stripes. They didn't look like the stripes were getting that much wider and fat. That may have been post-processing.
That's the number one value that comes through from position sensors coming out and saying that picking up was in meters.
So that's getting the flow. So is that's the now are you getting that through like
Yeah, so that's
There's a sample and the SDK is processing that though, or is that like?
That's already in the skeleton space.
Yeah. Oh, hang on, yes, so that's a skeleton.
Uh,
That'll be processing.